What is a horizontal asymptote? Horizontal asymptotes are essentially just imaginary horizontal lines that form on the graph. It happens when a function doesn't want to cross a certain y value at either the limit as f of x approaches infinity or the limit as f of x approaches negative infinity. The reason we don't just say the limit as f of x approaches positive and negative infinity is because there can actually be two horizontal asymptotes, like in y equals 2x divided by the square root of x squared plus 1. As you can see in the graph, a horizontal asymptote of negative 2 is approached when x approaches negative infinity, but there is also a horizontal asymptote of positive 2 when x approaches positive infinity. There are three possibilities when it comes to finding a horizontal asymptote. On each possibility, though, the focus is all about the monomial with the highest degree in both the numerator and the denominator. The first case is when the degree of the numerator is greater than the degree of the denominator. The second is when the degree of the numerator is less than the degree of the denominator, and the third is when both are equal. If the numerator is greater than the denominator, there is no horizontal asymptote. For example, the function y equals 5x to the fourth plus 7 divided by 3x plus 1 does not have a horizontal asymptote. This makes logical sense if we look at a table. As we can see, x to the fourth increases much faster than just the function x. For example, when we plug in 100, x to the fourth is 1 times 10 to the 8th, while x is just 10. This trend will continue, causing the function to essentially increase without bound. Graphically, we can also see that this is true. Because y has no boundary, there's no place that an imaginary horizontal line could go. If the numerator is less than the denominator, the horizontal asymptote has a value of y is equal to 0. For example, we can use the reciprocal of our function from the previous scenario. The greater exponent is now in the denominator, which causes this function to now have a horizontal asymptote of y equals 0. Because the base increases so much quicker than the numerator, it causes a function at a massive value to have so much greater of a denominator than a numerator. As we know, a bigger denominator leads to a value that is closer to 0. In the graph, we can also see that the end behavior approaches 0. If the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote has a value of y equals the ratio of the leading coefficients. They increase at the same rate, so it makes sense the next factor that would decide this is the leading coefficients. For example, y equals 8x squared plus 3 divided by 2x squared plus 5. From this, we would identify that the leading coefficients on both our x squared values are 8 in the numerator and 2 in the denominator. From this, we can get y equals 8 over 2, which is equal to 4. Graphically, we are also able to confirm this is true.